Hello everyone and welcome to Electronic Technocrat. Today we will learn about memory allocation and also see how arrays and pointers are implemented in C programming language. Basically, there are mainly two types of memory allocation in C programming language, that is static and dynamic. But in today's video, we will focus mainly on static memory allocation and also see how arrays and pointers are implemented in C programming language. So, without further delay, let's get started. Bring the introduction, please. All right then. So in today's video, we will be seeing six programs as you can see on the screen, and we will be starting over from the static memory allocation. So what is static? Static allocation of memory is specified by the user in a predetermined fashion and is controlled mainly by the compiler. So let's move on and see the program for static memory allocation. And as you can see on your screen, we have a program in which we have defined an int variable, char variable, a float variable, and a double variable. So as you can also see on your screen, we have a memory diagram. So you can see we have drawn around 8 byte of memory, and there are around 64 such bits over in that main memory, and that is what actually is your main memory. So that is just a representation of the main memory, and you can see there are around 8 bits in each rows, and there are such 8 rows in total. Okay, so the integer type memory or the variable int will take around 32 bits or 4 bytes inside the memory. The variable char in a memory will take around 1 byte or 8 bits, and the variable float will take around 32 bits or 4 bytes inside the memory. And lastly, the double type will take around 64 bits or 8 bytes inside the memory. Now, these all the memory which these all variable takes is generally architecture dependent, and currently I am running on 64-bit architecture. So for me, that is what they take inside the memory. For 32-bit, it might be different, but generally it remains somewhere around these only. Now there are certain qualifiers in C programming language which change the memory allocated to those variables, but we will be discussing them in another video. But for now, remember that that is how these all variables are stored inside your main memory. Okay, so this was the static memory allocation because we in a predetermined fashion told all these variables to be stored in such a fashion. So that is why it is known as static memory allocation. And the address where these variables will be stored is decided by the compiler. So we don't have any control over that. Okay, so the compiler will figure out all that mathematics and the arithmetics of where to exactly store those variables. But we will also see in a moment that how these memory are allocated to each of these variables. Okay, and now this program just simply allocates and initializes this variables, all of these, and then prints it. That's all this program does. So if you want me to print the output, I will just compile it. I will just say stat v and then compile this program. Okay, no error, and then I will just run it. And as you can see, as expected, 10 for I, C is equal to A, and F is 12.55, and these are all like it always prints out in 6 decimal up to 6 decimal, and same for the double. Okay, it just what is the difference between the float and double is that float is 32-bit and double is 64 bits. So they both follow the IEEE standard of storing the floats value. So that is how these static variables are stored inside your memory. Now let's head on and see the memory map of a C program in general. So as you can see on your screen, the memory map is as shown. Over at the end, we have the code area or the code segment where all of your code is stored. The code such as, I will just again make this visible. So you can see these all code hash include stdio.h. So that is the code. Then int main void. This is one code. And all of these codes such as printf's code, everything is stored in that code segment of the memory map. Above the code segment comes the BSS and the data segment. The initialized data segment, usually called simply the data segment, containing the variables that are specifically initialized in the program. For example, the C declaration int max count is equal to 99. Appearing outside any function causes this variable to be stored in the initialized data segment with its initial value. And uninitialized data segment, often called BSS segment, named after ancient assembler operator that stood for block started by symbol. Data in this segment is initialized by the kernel to the arithmetic zero or null pointer before the program starts executing. the C declaration int array, and in the square brackets 10 appearing outside any function causes this variable to be stored in the uninitialized data segment stack where automatic variables are stored along with the information that is saved each time a function is called. Each time a function is called, the address of where to return to and certain information about the caller's environment, such as some of the machine's register, are saved on the stack. The newly called function then allocates room on the stack for its automatic and temporary variable. This is how recursive functions in C can work. Each time a recursive function calls itself, a new stack frame is used, so one set of variables doesn't interfere with the variables from the another instance of the function. Heap, where dynamic memory allocation usually takes place. Historically, the heap has been located between the uninitialized data and the stack, and the stack memory is where the static memory allocation happens. Now, next we will look about ARR0.c. It might look cryptic name, but I will explain you what it does. So till now we have understood that how static memory allocation works. Now we also have understood that we don't have any control over where the variables are going to be stored. But what if we want variables so that they could be stored in a contiguous memory area or in a contiguous fashion? For example, I want to make something which will hold the number of days in each month of a particular year, like January has 31 and February has, depending upon leap year, 28 or 29 days, and so on. And I want these all those variables to store in such a fashion that they are in a sequence or in a contiguous fashion. Now, in order to do that, C gives us the ability to store variables in a contiguous fashion, and that is what is known as array. So let's look at a program of implementing array in C programming language. And over here, as you can see on your screen, I have implemented an integer type array which has about 5 elements: 1, 2, 3, 4, and 5, and I have printed each of those elements using a while loop. So this is how you implement array in a C program. There is another method also to implement array, but for now I will just show you this one, and later on I will also show the other way. And to print that each element inside the array, we have to implement something as a while loop. Now over here, if you look closely, I have initialized the index. This I variable will work as an index to each of these elements as 0. So the in C programming language, the index of the array always starts from 0. So the 1 is stored at the index number 0, then 2 is stored at the index number 1, 3 is stored at index number 2, and so on. So that is how I printed each of the element inside the array. Now let me just go ahead and compile this program. So I will compile this program and let me just run the program. So as you can see, at the index location 0, 1 is stored. At the index location 1, 2 is stored. At the index location 2, 3 is stored. So that is how array works in C programming language. And this all variables or these all elements of the array are stored in a contiguous memory area. Now, how do I know that these are all stored in a contiguous memory area? Well, because we can look at the memory address of each of these variables. So let me just go ahead and open that program again, and let me just do some kind of modification. Now, instead of printing each element inside this array, what I will do is print the address of the array or address of each element where it is stored by prefixing it with an ampersand. Okay, so what this ampersand does is it just prints the address of this particular element. Now you could prefix the ampersand sign to any variable to know its address. Okay, so that is how in C program you print the address. Now since I'm printing the address, what I will do is I will just modify it and just say that address of this particular element is equal to, now instead of using an I format specifier, we have what is known as a P format specifier for printing the address. Okay, so always remember to use P if you want to print address of any variable in C programming language. Now let me just go ahead and compile this program. Again, I have compiled. No error. That means everything looks good. I will run the program. And as you can see on the screen, it has printed address of each element inside the static variable segment. So that is how each of those elements were stored. And if you look closely, or rather, I will just open a diagrammatic view so you can visualize all that. So as you can see on the screen, I have a memory area, and all those blocks or rows which you are seeing are actually 4 bytes of memory. Okay, since this array was an integer type, so rather than having that single bits, to simplify it even more, I have just shown a row of 4 bytes, okay, or 32 bits. So this particular address will be stored in the first row of that memory. Now next will come in the second row. So this element will be stored in the second row. Now this will be stored in the third row in that memory diagram. And now this will be in the fourth row, and this will be in the fifth row. And other will be uninitialized because we haven't stored anything. And this array is just of 5 elements. Okay. So that is how it is stored. And if you look closely in the LSB side, each of these address differ by 4 bytes because it is an integer type array. That why it is differing by 4 bytes each. So this was address something something 30. This is something something 34. So the difference is 4 bytes. Over here as well, it's 4 bytes, and over here as well, it's 4, and over here it's 4 because this was an integer type array. If it had been a char type array, the difference would be of 1 byte only. Okay, so it depends on what data type is of the array. For the integer type data type, we have 4 bytes difference. So that is how it is stored. And we now know that it is stored in a contiguous fashion. So due to this, it opens door to the many possibilities of doing calculations and arithmetics in this way because everything is now stored in a linear form. So you can just address or you can just pick up those elements in a sequential form. Okay, so you just have to need an index or something which just will go to that particular location and take an element from the array. So you know exactly where each of those value are stored because you have that indexing facility in this array. Okay, so that is how the arrays are stored in C programming language. Now let's move on and see about another important aspect of C program.